Previous problem we talking about the kinetic problems by using the equation of motion in rectangular coordinate. So when particles move along the curved path, and it's made more convenient to write the equation of motion in terms of normal and tangential coordinates. Okay, and we have to know that normal directions n is always point toward to the path. Center of curvature is always toward to the center of curves. Okay, and tangential directions is tangent to the path. Okay, so for the normal and tangential coordinate system, we can set up the equation of motion. Is maybe for some problem, it's maybe more convenient to solve in terms of this type of coordinate system. Okay, so we have the in vector, we can write it in this form. That is summation of force in tangential direction plus the force in normal directions and also in the binormal directions equal to mass times the acceleration in tangential and in normal directions. Okay. For binormal direction, it is because the motion in normal and tangential coordinate system, we have just only two components of acceleration in tangential and in normal. So then there is no motion in binormal directions. We can write summation of F in binormal equal to 0 for this case. And for the acceleration, as we have studied from kinematics in normal and tangential coordinates, tangential acceleration represents the time rate of change in magnitude of the velocity. Okay, so the change in velocity, in magnitude of velocity represent the tangential acceleration. But for the case of the normal acceleration, it represents the time rate of change in direction of the velocity vector. So for the particle that change the directions of the velocity, okay, the change in direction represent the normal acceleration. And normal acceleration is determined by using the velocity square divided by rho. Rho represent the radius of curvature. And from calculus, we know that radius of curvature is determined by using this formula. So then it's not necessary to remember. I've given you the formula. Okay. And we will use the basic calculus to solve this. To solve the problem in this coordinate system, okay, we do the same thing. We set up normal and tangential coordinate system, okay, and we draw free body diagram on the left-hand side, kinetic diagram on the right-hand side, okay. Use consistent positive direction, okay. Acceleration and always acts inward, okay, the positive n direction. And tangential acceleration AT may act in either positive or negative t direction. Okay, so then we apply equation of motion and then we solve the problem. Okay, let's take a look for the example. Okay, the example here is the 12 kilogram blocks is confined to move along the smooth parabolic path. Okay, the attached spring restrict the motion, and due to the roller guide, it always remain horizontal as the block descends. If the spring has a stiffness of K equal to 10 Newton per meter, okay, and unstretched length is 0.5 meter. Okay, the mass of the roller and the spring, we can neglect it. Okay, we would like to determine the normal forces of the part on the block at the instant x when x equal to 1 meter. When x equal to 1 meter, okay. When the block had a speed, and the speed when at x equal to 1 meter is equal to 4 meter per second. Okay, and then we would like to determine the rate of increase in speed of block A at x equal to 1 meter. The rate of increase in speed means that this is AT. Okay, this is AT. The rate increase of the speed is acceleration. So how can we do this? We starting with set up the coordinate system. Okay, you see that for these cases, it's not convenient to solve the problem in XY coordinate system. Okay, so it's maybe better to solving it in normal and tangential coordinate. Okay, so we draw the free body diagram on the left hand side in normal and tangential coordinate system. And on the right hand side, it is the kinetic diagram that is follow the positive sign convention. For this case, positive sign convention is follow normal and tangential coordinate. Okay, is follow the normal and tangential coordinate. Okay, you see from the left hand side, you have the forces. The forces is the force of spring here. Okay, and the weight. Okay, and it is a normal force that is always normal to the block, normal to the part. It's always perpendicular to the part. And it has no friction because the problem mentioned that it is a smooth surface. Okay, and acceleration on the right hand side, we have the kinetics diagram. That is the acceleration is follow the tangential and normal coordinates. It's always like this. Okay, in order to determine an, okay, we use the curvature, right? So then for this slide, we determine for the curvature as first. Okay, for this case, we have the part equation. This is the part equation, that is the equation of part y equal to 3 minus 0.5 x squared. So it means that the slope dy by dx is equal to tan theta equal to, for this equation, we obtain it is minus x. So then when x equal to 1 meter, tan theta is become minus 1. That is mean that theta is minus 45 degree. So minus 1 is mean that the slope is going down. Okay, this is the decreasing in slope. Okay, and second derivative. Second derivative is what? From this equation, we do the second derivative. We obtain that the second derivative d2y by dx2 is become minus 1. Okay, so for this case, we can determine for the radius of curvature. Radius of curvature that is equal to this. So as I given you in the assignment before, that I asked for the definition of the curvature. In my opinion, the definition of the curvature is a change, is a rate of change in slope. Okay, this is the rate of change in slope. This curvature is a rate of change in slope. Okay, or rate of change in direction. Okay, so according to this, we can determine the radius of curvature over here. Okay, and after that, from the free body diagram and the kinetic diagram, okay, we can determine the elongation. Okay, for these cases at x equal to 1 meter. Okay, but the problem given us the unset length of spring is equal to 0.5 meter. So then the elongation of the spring is become 0.5 meter. We know that from the spring constant. Okay, this means that the force of the spring at x equal to 1 meter equal to 5 Newton. Okay, and the problem always also given us that x equal to 1 meter, velocity is become 4 meter per second. According to this velocity, we can determine for the normal acceleration that we already obtained the radius of curvature, and we found out the normal acceleration at this point is equal to 5.66 meter per second squared. So then we can form the equation of motion in two directions, that is in normal direction. Okay, you observe that the positive direction is the same directions of the normal directions, okay? And then according to this, we can form the equation of motion on the left hand side according to the forces. Okay, we decompose the weight into normal and tangential direction. Okay, and this is the normal force. This is in the same directions of normal direction. Okay, and after we form this equation, and we also know the mass and an we already determined. So then we can determine for the normal forces, that is 18.856 Newton. Okay, and in the same manner for tangential direction, the positive is the same as the positive tangent. Okay, so for this case, we can derive for the equation of motion in tangential directions of by this equation, and then after we substitute every value inside this equation, we can determine for acceleration in tangential direction equal to 6.642 meter per second square. And this is the answer. Okay, the answer is just only this. Okay, we back to the previously question. Okay, you have to conclude the solution correctly also. The problem asks us that the normal force, okay, that is the first answer, right? Normal force N. Okay, and the rate of increase in speed. This means that we ask AT. Okay, so for this problem, the solution become this one and this one. Okay, so for the student that answer the problem number 2 to be A total equal to 5.66, that is AN plus AT, that is 6.642 square. Okay, and you may get some solution here and you mark that it is the answer that is not correct. Okay, because we ask the change in speed, we change the change in speed, so then we ask actually AT, not total acceleration. Okay, you have to understand that. So then that completes this problem.